Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alright, today we will continue our lecture on Laplace transform. So, based on the past class, we have gone through what is the frequency response and also what is transfer functions. Okay, so when we have Laplace transform, XS, we can also have the Fourier transform that we will cover later. But let us focus on the transfer function, which is this one, HS. Okay, so HS basically can be can be transferred to frequency response by substituting S equivalent to J omega. Okay, so when you have HS, it can be frequency response, just substitute S J omega here. Okay, now we can find what is the variation of the frequency from the frequency response by finding its amplitude first. Okay, and also the angle of phase here, right? So if cos omega, if the frequency response is in terms of cos omega t, so that means we can have the amplitude here and also the phase here with the input as cos omega t. Okay, so how to calculate the amplitude and also frequency, which I have mentioned also before. Let's see this example. We have HS equivalent to S plus 0.1 over S plus 5. So we want to see what is the output if the response is here, HS, and given the input as this one, these two. Okay, I will repeat again this example. So we substitute HS to J omega. Okay, J omega now J omega now become J omega plus 0.1 divided by J omega plus 5. Okay, to find its amplitude, we use this formula. The value here, omega squared plus 0.01 square root divided by omega squared plus 25. Okay, so this is the amplitude. Okay, so now we can see that omega is actually can be varies. Okay, and for the phase, we take the value of the denominator because it's divided, so we minus here. Okay, so the omega divided by 0.1 minus uptangent omega divided by 5. This is to find the phase. Now you know how to find the amplitude and also the phase. Okay. All right, next, since we have the variable omega, we can plot the amplitude graph of these functions hg omega by finding its value of omega from 0 to some number. Okay, you can put any number just to make sure it you can plot. Okay, find some points. Okay, so when you substitute here h omega substitute with 0, 2, 5, 10. Okay, so you can get all these values. So that is how you plot. Okay, from the and then for the phase, so again you substitute omega 0 to some number to get the point. Okay, and then you can plot it. Okay, so now you have the frequency response of this function. Okay, what is the amplitude here and also the phase. Okay, this is the phase hg omega. Okay, here. Okay. All right, now the question also asking about what is the yt output if the input is cos 2t and xt. Okay, so now we will identify the omega of this function. Omega is 2 pi ft, 2 pi ft. Okay, pi ft. Okay, so here cos 2t, so that's mean omega is equivalent to 2. Okay, when you substitute 2 in these equations, you will get 0.372. and also you substitute 2 here in the equations, but actually you can find it in the equation itself. 2 here, so find the value of Hj omega. Alright, so since we have to know what is output T, so Yt equivalent to Hs multiplied by Xt. Okay, so you will, this is Hs, Ht. So Yt now become 0.372, the amplitude. Cos 2t is the input Xt. Okay, and then this is the shifted by this one. Okay, so this is how the input looks like. Sorry, this one input, and this is the output. Okay, your output is 0.372. Okay, the input is cos 2t. Okay, this is one. All right, for the second one, we have omega equal to 10. Okay, omega equivalent to 10. Now we substitute again. So this value will shows you 0.894 when you substitute in the amplitude, and when at the phase you can have 26 degree. So you just multiply it with the input, and this is the answer for the part B. Okay. All right. So right now we can plot the amplitude and phase of each frequency response functions. Okay. So if the frequency response is an ideal group delay or delay functions, so if you can recall the group delay or delay functions, we will put it as E minus ST. Okay, so now if you want to find the amplitude and the phase of this E minus ST, we can use this formula. So the amplitude is actually equivalent to 1 here, and the phase is this one, omega t, as equivalent to j omega. Okay, and then we plot here amplitude 1, and for the minus omega t, it will, because it's minus omega, so it will decrease like this way. Okay, so you just substitute the value of omega from 0 to some numbers. Okay, up to you to plot this type of graph. Okay, so this is how the delay E minus ST looks like for the magnitude plot and also the phase plot. Okay, this one, these two. And we also have ideal differentiator, which is equivalent to S. Okay, S when you convert to j omega is omega. So omega when you substitute is going to be increase here. Okay, depends on the value of omega. And the phase is minus j pi over 2. Here you we make S equal to 1. So this is the fixed value pi over 2. And the next one is the integrator 1 over S. So you just find the, substitute the value of this one, amplitude, and also this one, the phase. Okay. So that is some of the example. How do we plot the magnitude and also the phase? Okay. All right. The next subtopic that we want to cover is the bilateral Laplace transform. Okay. Why it called bilateral? Because previously we have seen the Laplace transform, and there is also a table. Okay. From the table, let me just scroll again. Okay, so this one, if you could recall when we learn about unilateral. Okay, so why they call it unilateral? Because it only exists in one side. It is a causal functions where it exists from TUT. Okay, you can see here TUT. So what means TUT? It start from 0 and to the right. Okay, to the positive number, or from to infinity. start from 0. Okay, so that's why it's called uni. That means it only this table only can be used for TUT. Okay, that means a function t is like this. Okay, but it only exists from positive to here, infinity. So it does not exist at the negative side. Okay, but now we want to learn about bilateral Laplace transform. Okay, so when we are talking about bilateral Laplace transform, that means we have two sides. Okay, where is that? Okay, this one. Okay, so for two-sided means we have from minus infinity to infinity. So this function exists here to here. Okay, from minus infinity to infinity. So previously we only consider this side only, positive side only. Okay, so again S will be equivalent to sigma plus j omega. Okay, so how we going to do this transformation? We will deal with a signal or system that is non-causal. Okay, so this is called non-causal, this is causal. Okay, all right, so if we have two-sided Laplace transform, that means we will have remember that how we transform a function xt to become xs, the function itself xt will be multiplied by e minus st. Okay, so this is the equations. Okay, whatever the functions, you multiply e minus st. The difference with unilateral, unilateral will have this starting at 0, okay, to infinity, but for bilateral we have minus infinity to infinity. So that's mean we have two sides. Okay, so that's mean we are going to have x1s here and x2s. So we will separate these two as two equations we added. Okay, so it is going to be called x2s plus x1s, this one and this one. Okay, so the x1s we have no problem. Okay, this one, so we can use this one using a table. Okay, but for this one, okay, since we don't have a specific table for the minus ut, so we are going to convert the u minus t to ut. Okay, how to do that? Okay, so consider the second function x2s, which is at the non-causal part here. Okay, this is x2s. Okay, so now x2s from minus infinity to 0. Okay, xt e minus st dt. Okay, okay, so we want to make it a causal function, so we want to put it here at this location, causal, so it will become now 0 to infinity. Okay, but what we want to do, we will flip it. Okay, so if we want to flip it, we will have to put this one, whatever the function t, become minus t. Okay, all right, so now that's mean if we have changed it to minus t, the frequency function xs now become x minus s, but the inner value of t will become minus t. Okay, so if we have this one from 0 to infinity, so that's mean we have x minus t is a causal, and x2es, since it's a causal, can be found from the table. So we just transform this function into Laplace, which is in S function. Okay, but after that we will change it back to plus S, and we can find the equation. Okay, the solution, right? Okay, so for example, we have xt. Okay, so we will do now a function xt equivalent to, let's take exponential as example, EBT u minus t, so this is non-causal, plus EAT ut. Okay, so if you can see here, this is causal and this is anti-causal. Okay, why? Because it start at minus t, it exists at minus t. So that's mean we have a function here and also function here. Okay, so this is EB and this is EAT. Okay, this is EBT. Okay, so one at u minus t and another one at ut. Okay, all right, so for this one we know that the Laplace transform is, this one can refer to the table, so 1 over s minus a. Okay, so this at, so divide by a. But for the second function, okay, so this one is settled. Okay, for the second function we name it as x2t. So t equivalent to EBT u minus t. Okay, all right, so we want to make this one causal. Okay, so now we will put it as t flip. Okay, so become e minus bt ut. Okay, so it's already flip here. Now what we do is we find the Laplace for this one. Okay, so now it become x2 minus s 1 over s plus b. Okay, all right, so since this is e minus x, so we want to change now x to s. Okay, so what we do, 1 over minus s plus b. Okay, so this is the xs. Okay, but since we don't want to have the s in negative, okay, so we will multiply these two with minus 1. Okay, so now it become minus 1 divided by s plus b. Okay, so this is the function e bt u minus t. Okay, sorry, okay, u minus t. Okay, now we have convert the causal part and also the anti-causal part. Remember, there are two functions. Okay, so since the equation wants us to find the total solution, so we will just combine again xs equivalent to 1 over s minus b. This is the anti-causal function that we have convert to Laplace, plus this is the causal function that we just do at the first place. So now it become 1 over s minus b, s minus a, and this is a minus b. Okay, all right, so right now we will have a function, the transformation from this one, okay, which have two sides, e u e bt u e minus t and e a t u t. We convert it using bilateral technique. Okay, and we have this function a minus b, s minus b, and s minus a. Okay, so for this part is a causal function, so we will going to have the roots s. For a causal function, it's this side. Okay, so s larger than a. Okay, for the this one is anti-causal, so S will be less than B. Okay, so basically we have this as A and this is B, for example. We will have this as a region of convergence. Okay, so basically RES will be less than B and larger than A. Okay, so again, okay, so it's actually like this, less RES less than B. Okay, okay, so this is the region of convergence. Okay, let's see one more example. We use a real number example. If we have XS equivalent to, just now we convert from T to S. Okay, so this time we use the inverse Laplace, S plus 2 multiplied by S minus 1. Okay, so find the inverse Laplace transform. Okay, so the region of convergence is, we know this is the roots. Okay, so it's from 1, okay, and minus 2. Okay, so it gives to you this is the region of convergence. Okay, so what we are going to do now, we have to put it part by part, so equivalent to using the partial fraction equation. So you will have 1 over S plus 2 minus 1 over S minus 1. Okay, okay, now we know that for this function, this is anti-causal, and this part is the, for this part is a causal, and this part is anti-causal because it to the right. Okay, okay, so remember, for anti-causal it to the right and anti-causal to the left. Okay, so when we want to substitute this to xt is equivalent to e minus 2t. Okay, so this is causal ut. Okay, plus, change this one to Laplace, e minus t plus minus, so you can plus et. And then what is the suitable function for here? Since it's anti-causal, one is anti-causal to the left. Okay, so ue minus t. Okay, so it depends on your roots and where does it covers the region of convergence, to the left or to the right. Okay, so let's say the same equation, okay, but the region of convergence says that S larger than 1. Okay, this is 1. Okay, here, so S larger than 1. Okay, so we will, okay, this is different question, yeah. So it's going to be, if S larger than 1, mean to the right, right? Okay, so we will have E minus 2t plus et. Okay, both are to the right, so ut. Okay, but if they shows that region of conversion to the left, okay, so this is another case, region to the left, e to t, the same equation, plus et, so to the left u minus t. Okay, all right, so I will share one more example. If we have function xt, now we want to change to Laplace t to s. Okay, so e 3t ut, sorry, u minus t plus e to t ut. Okay, so this means this one is causal, okay, and this one is anti-causal, okay, the minus one. Okay, now we want to change this one, the anti-causal, to become causal. So e, the minus t become t, so t become minus t, so e 3t ut, okay, plus this is maintained e 2t ut. Okay, so now both become causal. Yeah, this one we flip to make this one causal. Okay, so now we change to xs. Okay, 1 over s plus 3 plus 1 over s minus 2. Okay, but this one is actually we changed just now, right? So we have to change it again. So 1 over minus s plus 3. Okay, so now we don't have like a depth to this one because we already changed here. Now we change it back, okay, to minus s plus 1 over s minus 2. Okay, so this one, remember, because we are dealing this one with the anticausal, we change to minus t and find the Laplace transform, and if it's already transformed, we change the sign of s. Okay, all right, so we don't want this one to have s, so we multiply with minus 1, so now become minus 1 divided by s minus 3 plus 1 over s minus 2. Okay, so this part is maintained, no problem, only we play around with this one. Okay, first of all, change it to minus t and then find the Laplace transform and then change it to s to minus s, or vice versa. Okay, and now we want to find the region of convergence of this signal. I will just show here for this part. This is causal part, right, to the right. So s minus 2 is larger than 0. Okay, so s larger than 2. Okay, and the second part is s minus 3. For this part is anticausal, so it's to the left, so less than 0. So s less than 3. So the region of convergence from larger than 2 and less than 3. Okay, so here larger than 2, here less than 3 is here. Okay, so this is the region of convergence. Okay, I'll show you another example. Okay, xt equivalent to e minus 4t ut, okay, plus 2e minus 5t. So this one is anticausal u minus t. Okay, so anticausal, and this one causal. Okay, so change the anticausal part. So now it become e minus 4t ut plus 2e minus 5t now become 5t ut. Yeah, the both are causal. Okay, so we change this one to Laplace. Xs become 1 over s plus 4 plus 2 divided by S 5 minus 5. Okay, all right, so don't forget to change this one because here is we just change it just now. So now it become 1 over S plus 4. This maintained because it's causal, plus 2 divided by minus S minus 5. Okay, all right, now we don't want this one, so 1 over S plus 4 minus 2 divided by S plus 5. Okay, multiply this one by minus 1. Okay, and for the previous example, okay, we seen that all the region of convergence is stripped, right? But for this one, we will check region of convergence. Okay, so if it's stripped here, so means we can find out the Laplace transform is exists. Okay, so for this one, S plus 4 larger than 0. Why? Because this one is the causal part. Okay, so S larger than minus 4. Okay, and then the second one, okay, S, the second one, which the anticausal, S plus 5 is less than 0. Okay, because it's anticausal, so S less than minus 5. Okay, so that's mean that we gonna have minus 4 larger than, okay, here, and minus 5 less than. Okay, so in this example, the region of convergence is not stripped. Okay, it's not meet here, so actually the LT is not exist for this one. Okay, if strip, the LT is exists. Okay, just like this example, this one. Okay, LT exists. Okay, I have another one. Okay, XS equivalent to 2S plus 5 divided by S plus 2 S plus 3. Okay, now you want to find the the xt. Okay, so we're going to break it up, partial fraction. So a divided by S plus 2 plus b S plus 3. Okay, so for a, S2 S plus 5 divided by S plus 3, substituted by S minus 2, S2, the second one, so it's going to have 1, and B 2S plus 5 divided by S plus 2, this one S into minus 3, so it can become to 1. So the equation now 1 over S plus 2 plus S plus 3. Okay, right, so here we can find the inverse by E minus 2t plus E3t. Okay, so how we want to find the whether it's causal or not? Okay, so we plot the roots. Okay, minus 2 and minus 3. Okay, so if we assume this is strip, okay, or converge, so the LT is exists, so we will decide. So for minus 2 is to the left, right, and minus 3 is to the right, so we can decide here minus 3t to the right, so to the right is causal ut, and to the left is minus t, which is anti-causal. Okay, so this is in the time domain, right? Okay, last example is from the textbook. If we see here, find the response yt of a system with the transfer function 1 over s plus 5. Okay, so re actually larger than minus 5. Okay, right, and the input is e minus t ut plus e minus 2t u minus t. Okay, so this is the transfer function and this is the input. Okay, but we have to find the yt. Okay, so first of all we have to convert the input x1. So this is x1 and this is x2. Okay, so x1s equivalent to 1 over s plus 1 and x2s 1 over s plus 2. Okay, all right, so before that we know that the minus 2 is a anticausal, right? Okay, so what we do is we have to change this one to, we do it here, this is x2 e2t ut. Okay, so we change this one from anticausal to causal, so we change the t from minus to positive, so the xs 1 over s plus 2. Okay, but this one is, we change it to minus t just now, so now x minus s become 1 over minus s plus 2. Okay, okay, here we remove this, so minus 1 divided by s minus 2. Okay, okay, to find the ys, okay, you have to multiply hs and xs. Okay, so 1 over s plus 1 is the input, multiplied by 1 over s plus 5 is the transfer function. Okay, we do the PF here, it become 1 minus 1 over 4 s plus 1 minus 1 over 4 divided by s plus 5. Okay, so that is the first one. Okay, y1s, y2s, the second function, which is the anticausal part, is minus 1 over s minus 2. So minus 1 over s plus 2 multiplied by the hs 1 over s plus 5. Okay, multiply, so equal to 1 over 3 divided by s plus 2, find the PFE, plus 1 over 3 divided by s plus 5. Okay, alright, now we can change both to Laplace transform. y1t equivalent to 1 over 4 e minus t minus e minus 5t. Okay, this part is causal ut, and y to t 1 over 3 e minus 2t u minus t plus e 5t ut. Okay, so we have to combine these two. Y t total is equivalent to y1t plus y2t. Right, so if you can find the transformations, okay, with the proper um, way, so you can solve this one. Okay, so basically for the bilateral, again I will repeat the steps. Okay, we identify which are the causal part, which one are the anti-causal part. Okay, okay, so for the causal part is ut, the anti-causal part is u minus t. Okay, so we want to flip the u minus t to here, so there will be two causal part. Okay, so this one, the u minus t, you change it to t. Okay, flip it, number one. Okay, number two, transform t to s. Okay, so this is number two, and then the s change to minus s. Okay, so this will be the third steps, and then you will find the correct bilateral Laplace transform. Okay, change this one. Okay, okay, so one more tips, if we don't want it to become minus s, you multiply with minus 1 at the numerator and denominator, so it will become minus s will become s back. Okay, but in it after you change this one. Okay, so that's all for this chapter. Next week we will start the new chapter. Okay, so thank you for your attention. Assalamualaikum warahmatullahi taala wabarakatuh.